Hi again. We're now going to go ahead and find a solution to an initial value problem for a homogeneous second order differential equation. Here we have y double prime minus 4y prime plus 3y equals 0, with the initial conditions y of 0 equals 7 and y prime of 0 equals 11. Now this is going to be an example where we do have distinct roots to the characteristic equation. Let's see how that plays out. We're going to have r squared minus 4r plus 3 equals 0. So this factors as r minus 3, r minus 1 equals 0. So we get r equals 3 or 1, and we can quickly get the general solution. Y sub g of t equals c1 e to the 3t plus c2 e to the t. So we want to get where it's that quick and simple, that fast, for us to be able to come up with the general solution to one of these homogeneous second order differential equations. It's such a mouthful. I've said it so many times today. So now we want to take the general solution and find the particular solution that has the initial conditions y of 0 equals 7 and y prime of 0 equals 11. So to do that, we're going to start by taking the derivative so that I get the y prime of t. So y prime sub g of t equals 3c1 e to the 3t plus c2 e to the t. And then we'll go ahead and plug in the initial conditions to the original function, y of 0 equals 7. So that's my initial condition. When I plug that into y equals c1 e to the 3t plus c2 e to the t, we're going to get 7. Actually, I'm going to write it in the other order. I'm going to get c1 e to the 0 plus c2 e to the 0 equals 7, which simplifies down to c1 plus c2 equals 7. For y prime of 0 equals 11, we plug that into the derivative. Y prime equals 3c1 e to the 3t plus c2 e to the t, and we'll get 3c1 plus c2 equals 11, where I plugged in 0 for t in the exponentials and they've just canceled out to 1s. So with this, we're going to go ahead and set up our matrix, our augmented matrix, 1, 1, 7, and 3, 1, 11, with our augmentation line between the second and third columns. We can then go ahead and do our first line. I'm going to take row 2, and it's going to go to negative 3r1 plus r2. And so when we do that, we'll get 1, 1, augmentation line 7 for our top row. And then our bottom row, by design, the bottom left is going to be a 0. When I take the top row, negative 3 times 1 is negative 3 plus 1 is going to give us a negative 2 in the second column, second row. And then in the third column, second row, we'll get negative 3 times 7 is negative 21, plus 11 is negative 10. I'll then take row 2 and have it go divide by negative 2 to put a 1 in the pivot position. So we'll get 1, 1, 7 for the first row, then 0, 1, 5 for the second row. And next, we're going to get a 0 in the second column, first row position to finish getting our row reduced matrix here. The bottom row is going to stay as 0, 1, 5. The top row is 1, 0, and then we got to figure out what happens to that 7. So to do this, we're going to take the first row, and it's going to become the negative of the second row plus the first row. And so when we do that, the negative 5 plus 7 is going to give us a 2. So this shows us that C1 equals 2 and C2 equals 5. So we can say that our particular solution to this differential equation is y sub p of t equals 2 e to the 3t plus 5e to the t. And this particular solution will satisfy the initial conditions y of 0 equals 7 and y prime of 0 equals 11.